Okay, testing. Alright, that looks good. Okay, so this is part 8 of converting a Cr10S-Pro 3D printer to a Voron Switchwire. We are changing it up this time around. We are on, what does it look like? That, do I have to close it? Oh, it's because I'm looking at, okay, that makes sense. So if I stop looking at it, yeah, okay, there we go. Very cool. All right. So, yeah, so this is part 8 of converting a Cr10S-Pro 3D printer to a Voron Switchwire. Now we are on to the software side of things, so we're pretty much done with the hardware for now. Last episode, I suppose, I basically finished up the wiring. Um, Aside from the touchscreen, I did end up figuring out how the touchscreen was supposed to be powered. It just was powered with that one ribbon cable, but the contact points were flipped. So once I flipped that over, it worked. Unfortunately, I was not able to actually get it to display anything. So that's going to be a bit of a process. I spent a lot of time troubleshooting it. Still haven't gotten anywhere, and the company that makes that screen is located in China. And when I emailed support, they replied with like a generic that we're having a holiday or something. So uh, reply back in 7 days or something. So that while I'm waiting on that, we're actually going to get into the uh, Mainsail installation, which I did already basically get Mainsail installed on the Pi, and then get the firmware actually um, configured and set up on the device. So if you don't know what Mainsail is, it is, and I guess we can also get to Clipper screen as well, even though that's not going to work properly right yet. But yeah, Mainsail is basically a well, it isn't. I mean, is it considered the firmware? Yeah, Mainsail is like a platform for the controller board firmware, essentially. So the firmware itself is Clipper, and what makes Clipper firmware unique to, and why pretty much every hobbyist 3D printer that you buy nowadays runs on Clipper or some sort of like proprietary fork of Clipper, usually, is that it's just way more improved than the previous one. I forget what that firmware was, but there was a previous firmware that reigned supreme before Clipper. And what Clipper does is it uses either a Raspberry Pi or some sort of equivalent to that to handle all of like the heavy duty processing, and then it just gives those processed sort of commands to the main board to then execute them on the printer. So it basically allows you to have just a it allows you to run a printer with more features, more options, and it allows you to just print faster and print it like higher accelerations and have better quality overall because of that, essentially. At least that's my understanding of it. And there are multiple different platforms from which you can access, like set up the Clipper firmware. Mainsail is kind of, I guess, the main one. I think that's probably the number one that people are using. The other two are Fluid and Octopi. um, specifically the Clipper variant of that, because there's like the normal version of Octoprint, which is just like it's just a way to be able to access your printer remotely and run, commands and stuff remotely through a console without having to do anything on the physically on the printer, I guess you could say. But yeah, so we're going to be using Mainsail. It's the one that I think pretty much everyone uses, most people use at this point. So I I will boot into the Pi. Um, let's see if it's saved. Yes, it did save. Okay, so I am on Linux right now. Pr if you're watching this, very high chance that you're going to be on a Windows device. If you boot up your Pi, um, and you've got the Raspberry Pi, and we already installed Mainsail OS on it last time, but you boot it up, uh, and if you use the Raspberry Pi imager and configured your Wi-Fi settings and enabled SSH there, then you boot it up and you don't have to boot it up on a screen and then use that screen to like figure out what the IP address is and all that. You can basically do what's called like a headless setup or a headless install, where you don't need a screen or a monitor or anything like that, and you can remote into it from another device via SSH. So with a Linux operating system, you can do it directly from the command line. If you're running a Windows operating system, or I think you could also probably do it um, if you're on a Mac, uh, because they have the same sort of terminal that Linux has. So you could probably just use that same SSH command on a Mac. But if you're on a Windows, you can use PuTTY, which is this application. Um, but yeah, it's basically an application called PuTTY. See if it can get nope. But yeah, it's an application that you can then use to SSH into stuff from a Windows device, and you just need to figure out the IP address, and you can figure out the IP address by um, you can download like a IP scanner application. You can just type in IP scanner, and you'll find it. Um, and then you can scan your local subnet, assuming that you're like doing this from your home. If you're doing this in a enterprise environment, uh, that's a bit of a different story, and it would probably be better for you to, well, you can, if you know what subnet it's going to be on, then you can determine what the subnet is. But for the purposes of this, you just run the scanner from your home network. It'll only detect any devices that are on that network, and then it'll detect the Pi. It'll give you the IP address, and then you can enter that IP address into PuTTY, and then you can set it up. There's plenty of tutorials about how to use that, so I'm not going to go on too much about that. But regardless, if you're on a Linux, or most likely if you're doing this on a Mac, you can just run this command SSH, and then the username that you put for the Pi, and then at and the IP address. So we hit enter. It's going to ask for the password. I'm going to enter that now. Okay, so now we're in. You can see it says Mainsail OS. So next up, we are going to, I already did this, but for the purposes of just showing you what I did, you run sudo, and that basically is like a shorthand for admin. So it basically gives admin privileges to the command that you're about to run on Linux. And this is, and I should mention, Mainsail OS is essentially like a hyper specific. It essentially runs off of Linux commands, specifically uh, Debian Ubuntu-based Linux, which is the most common for desktops, and also Linux Mint and all that. But anyway, so it's going to be the same commands if you're on a Linux device, is basically what I'm saying. So sudo apt and then git update, and then again admin, so it's asking for the password. And then it'll do its thing. Check. I did this recently, so it's probably not going to take, yeah. So that's done, and then you can do sudo apt-get upgrade, and that's just going to upgrade anything that is on here that it can. Looks like it can upgrade some stuff. Then I guess while that's working, I can show you Raspberry Pi Imager. So this is what we used last time. You choose the Pi that you're using for this. I'm using a Pi 4. You choose the OS. In this case, it was Mainsail. So specific purpose OS, and then 3D printing, and then Mainsail OS, this one, and then you choose the storage, and then it'll give you the settings to configure the Wi-Fi and all that. Also, I should also mention about this imager something that I didn't realize until a couple days ago. Just because something doesn't appear in this list of operating systems doesn't mean that you can't still do things like configure Wi-Fi for it. Um, if it is a like actual Raspberry Pi specific version of an operating system, because like typical operating systems, even if it says that it's like for an ARM based CPU, so which is what the Raspberry Pi runs on. It runs off of an ARM-based CPU instead of like I think they're called 86, x86, x64 CPUs, which is those are the Intel and AMD CPUs that basically every uh, laptop or every desktop pretty much uses. Vast majority of them use it uses an ARM, but it also has specific hardware aside from that that it needs a specific kind of image other than the general one. But if it does have that specific kind of image, you can go in here and select to the bottom, hit use custom, and select that image. And when you do that, and then you do choose storage, and then you select it, and then you go next, it will still give you the options to do things like configure Wi-Fi and all that stuff, which is incredibly useful, especially if you do need to run a headless setup on something like Rocky Linux, for example, which is a version of Linux that is very much not on that list, but it does have a Raspberry Pi specific version. So anyway, that update is done. What did I just do? I pressed a key. Home? No. Page up? No. The Windows key? What did I do? Page down? Just a sec. Cancel. Hold on. brings up that. Applications. Like hit this part of the keyboard. No. Hmm. Leave full screen. Okay, there we go. Okay, so now with all that done, we'll move on to installing Clipper Screen just because this is the next step. So this is my first time doing this specifically. Wait. Where did... Is OBS... Oh. Oh. I guess we're still live. Okay, we're still okay. It's weird because OBS isn't... Oh, I guess if it's running in the background, it's fine. Just want to double check. Yep, okay. I think we are fine. We're fine. Okay. So, we will move on. Okay, so GitHub. Downloading text files from GitHub. Click the right. Oh no, that is okay, yeah. So we just it's annoying when it does that. Okay. Open link in new tab. Okay, there we go. So let us go to the instructions. Should image like this to the SD card. Update sudo install git. Ah, okay. I am aware of what git is. So that git, to my understanding, specifically relates to GitHub repositories, and I'm assuming the reason why we are, if it's not already, okay, it was already installed, is, yeah, so Git allows you to clone repositories and install them relatively easily. So cd, okay, so cd to this like ellipses basically takes us to the home directory, and then it's going to clone this GitHub to the files from the GitHub to the home directory, and then this command actually starts the GitHub. Like it runs the files. So it's cloning. There we go. And now we're gonna run it. Okay. Version 6. Many improvements. Some bugs may occur. I guess we'll just go with, let's go with the new version for now. Okay, perform action. Clipper installed, Moonraker installed, config. It says Clipper screen is installed. We will reinstall it just for the sake of it because I did run other commands to try and install it. So install Clipper screen. Yep, overwrite it. And answer yes to everything. This, I'm probably just gonna go with the first one. Okay. Install. Okay. So that should be it for Clipper screen. Okay. So now we're gonna get into the actual software configuration. So right here, this is actually me accessing the Pi right now. Um, so I entered the address of the Pi into the web browser, and then that takes you to Mainsail itself. Now you can see there's an error, and the reason there's an error is because we don't have the printer.cfg file. And the printer.cfg file is the big configuration file where you basically tell um, the printer like what the main board is, what each of the different like connections of the main board are called, like what points to what, essentially. Um, yeah, so it's a lot. It would be very challenging to do it on your own. Luckily, they do provide a version for us to at least work with because obviously we will have to make some adjustments. But for now, I mean, it's more than fine. So let's begin. So Switchwire, firmware. Let's see, stealth burner integration. Okay. Added track pins, sensors, config. Stealth burner integration. SKR Mini E3V3. E3V2. E3V2. Yeah, okay. Pretty sure we have an E3V2. I'm gonna be right back to make sure that's the right board, but okay. Yes, we do. We have the SKR Mini E3V2. E3V2. So we are going to this things to change and check. Okay. Yep, PID10. Okay. So it's download. Wait, no. It's a raw. That's what needs to be. Download, is that what it's? Oh, okay. Hold on. Gotta open it in a new tab. Okay. The raw browser's save as function. Okay. So I'm just gonna go into downloads where I downloaded that. We're going to delete that. And we are gonna go specifically to the v2 config, raw, and then what was it called? Save as function. Save page as, config, save. That's nifty. I've never done that before. Okay. Yep, rename it to printer.cfg. It has to be named printer.cfg, I remember that. Okay. The file via Mainsail's interface. Oh, yep, go to the machine tab, config files, upload file. Yep, okay. So, yeah, we go to machine, and then, yeah, so we've already got these files from just installing the OS. If you wanted to do this manually, you'd have to like enter the commands to install all these things manually, which again, you wouldn't need to do if you didn't have what you would need to do if you weren't using a normal Raspberry Pi, I guess, if you were using something weird like I think Big Tree Tech has like a lot of like Raspberry Pi clones, but they're like specifically meant to be used for 3D printing. But anyway, so we will go to create directory, create file. Where is the upload button? Or I mean, can't you just... Yeah, there we go. All right, printer.cfg is in. Okay, Mainsail, upload the file. Face, go to the machine. Yep, okay. All right, printer.cfg. Okay, so yeah, this is just saying that if you want to edit the printer.cfg file from within here, oh, we'll just add that. Ah, okay. So that just rebooted the Pi. So, yep, we got a connection failed. So, give that a second. Once the Pi boots back up, we should have that working again. If not, give me a minute and I can unplug it and plug it back in. Speaking of which, there we go. Okay. So, yeah, we still have an error, but as you can see, the error has changed. So, sensor type in the section heater bed must be specified. Once the underlying issue is corrected, use the restart command. Okay. I know there's like a printer CFG. You know what? I could probably use 10S-Pro. .cfg file. Okay, let's start with Reddit. This is the base I used. Okay. All right. So in here we can probably find what we're looking for. Heater bed. Okay. this back up. So now we're going to go into printer, config, printer, MCU. So this needs to be changed. Yeah, okay, I remember that. So basically, I forget exactly. Uh, we'll get to it. We'll get to it. But first, let's go to the extruder settings. So these are like the pins again, telling it where on the circuit board is the correct places. The thermistor you have. Okay. For the thermistor, I'm using the okay. We will check that first. But yeah, the thermistor I'm using is the E3D V6 thermistor that like goes right into that heat block. Configuration reference. Yeah, so serial port that connects the, yeah. So this is the way to actually flash the firmware from the Pi onto the board itself. So that's basically giving you like the port number, and you actually have to enter that. Now, stepper, yeah, Core XE. All right, we're just gonna go Control F. Thermistor. Oh, there we go. Thermistor. Okay. I do not think that. No, because it's not a common thermistors. Okay. Input pin. Generic. But the heater bed, we can get to that. So okay, heater bed, sensor type. This guy. Okay, so now that sensor is good. We're going to save and restart. And then that error should be gone. But another one is going to pop up. Aha, okay. End stop pin must be specified. And stepper Y, so that is the bed. I'm going to go back. Stepper settings Y, stepper setting. Okay. Uncomment one of the following. Switch-based end stop for Y or sensorless. Okay, so we have a switch, so we're going to uncomment this one. I'm not going to hit enter, we're going to uncomment. And we are going to save and restart again. And then another error is going to pop up. Sensor type in extruder must be specified. Date value below when you perform extruder calibration. Yep, that will be done at some point. Okay, gear ratio, heater pin. Check what thermistor type you have. Yep. Sensor type. Okay. So that's what it is. Since I know what the, okay. What is the store for the E3D E3D V6 hot end called 3D V6 systemic 104 NT systemic for GT cartridge style design Molex connector. Yep. Okay. So it looks to be 304 NT. Okay, so let's 104 GT. So let's put that in here and see if GT. Aha. 104 GT or 104 NT. I think we are going to start with this one. See if that works. I mean, actually, at this point, that isn't going to work because it's not. That one sensor currently isn't plugged into the printer because of how the wiring, the way that Voron decided to do it when they had the wiring of the main board is they didn't clearly have for that sensor which one was ground and which one was power. So I don't know if it's the same as like the fans in the other. It probably is, but I don't want to risk anything. Which, by the way, I would have started this a little earlier if I hadn't plugged the printer in and then the what's it called? Uh, the power regulator that I was using to power the Pi, which luckily the Pi wasn't plugged in, one of the two capacitors on that decided to not really explode, but it essentially burst. Um, so yeah, that was a little something. Luckily, the main board seems to be fine, um, but that was definitely something. So anyway, that is what we're gonna use. I don't know if I copied it. So we're gonna copy that in right there. And we are gonna save and restart again. We're gonna get another error. Or maybe we're not. No, we should. Hmm. Restart the firmware one more time. Oh, I think it's because it's like you would get the MCU is not present error, but there is technically an MCU. Um, yeah, okay. So it is there. Like if this line right here wasn't here, then you'd get like the MCU not um, something something error. But yeah. So now should be, I'll double check. Um, yeah, review it. Case sensitive. Keywords are lowercase. This doesn't auto capitalize keywords. Yep. Yeah, so MCU passed. Yep, thermistor types. We've got those. The MCU path we will do in just a sec. Stepper settings. Ooh, XYZ extruder. Position, max position, stepper type. Okay. That. And stop position. I mean, the end stop position is like the stepper end stop is on the carriage. So don't know exactly what that is referring to exactly, but this is stepper X, stepper Y. Yeah, position end stop. So these will be changed. The distances for these will be changed. I'll probably, once I'm done with all this, create a GitHub that has all this and the configuration file and all that. Uh, so this is just kind of going through the process. But let's see, is there anything else? So yeah, I'll modify the stepper settings in my own time. Uh, bed screw, tilt, quadrant. Okay, so yeah, this stuff is basically whether or not you have a Z bed leveling sensor. In my case, I do, so you wouldn't need to. Like, there's a way you can not need a sensor, um, and you can have settings for the bed screws and basically make it so you are like you map the bed ahead of time um, without having to need to like map it every time with a sensor. But we have a sensor, and I will configure that later because that is going to be a bit of a headache. It was a headache when I had it with. It could actually be less because I'm using a supposedly better board for it, but we will see. Anyway, so enter definitions. Yeah, okay. Let's just change the MCU path right now. So, yeah, okay. So this X is just a placeholder. So the MCU is connected to the Pi. The main board is connected to the Pi. So we just gotta copy this command over. Paste it up. Wait a minute. We need to get into the Pi again. So we are in. paste this guy in there. Okay. Sensor. Is that supposed to? Okay. Maybe I need to. USB leaf labs. Total 0. Serials USB. Okay. Let's let us consult the browser, see what it thinks about this. Output shows Leaf Labs board. Okay, is connected. All right. Specifically that the device is named yes, is linked serial. Okay. Yep. Okay, so it does see the board. Needs persistent symbolic links. This is. You may have not currently yes. File and flash clipper firmware 2 maple board yes. Okay. Connect. Yep. So we've done that. Navigate to your Clipper directory and start the configuration. Okay, so why isn't that? Maybe I'm jumping ahead here. Details, update controller. Okay, okay. Begin with all controllers disconnected from the Raspberry Pi. Printers with just one controller. USB Clipper. Begin with all controllers disconnect. Okay. I will be right back. Okay, the controller is now disconnected, or the main board is disconnected. Is this going to do anything else? Begin with all controllers. Printers with just one control. Oh. Okay, I'll be right back. Okay, I'm back. Hmm. The device identifier word is the word Marlin. Oh yeah, Marlin is the OG firmware everybody used, but Reload the Clipper firmware to a temporary text file. Only applies to printers with more than one control. Okay. Reload the Clipper firmware. Oh yeah, okay. Okay. Firmware flashing. Alright. SKR Mini E3D V2. Yes, V2.0. Okay. Clipper must be installed. Yep. At least one micro SD card needs to be available depending on the number of controllers. Yep. The Raspberry Pi. Ah, this, okay, I remember this now. Okay. Sudo apt install make. I'm gonna double check and make sure. Yep, I'm still going. And you can hear me. Good. Okay. All right. Let's do this. Get off of that. Yep. So install make. Done. Okay. Manually installed. CD Clipper. So this is going to take us to the Clipper directory within the Mainsail OS while remoting in. So now we're in the Clipper directory. And now make menu config. So this is going to give us like a selection of what specific version of Clipper firmware we need. There we go. Okay, so microcontroller architecture is set to the ATmega. I think that was the one I used before. To STM32. STM32. Okay. Processor model STM32F103. Bootloader set to 28 KIB. Communication interface. Check that the clock. I mean, there is nothing about the clock, so that USB for communication. Instead of serial, yep, we've got USB. Okay. Enable extra. Clock reference, yep, that's set to 8. Extra low level configure, yep. USB, GPIO pins, set at microcontroller setup, includes exclamation point, PA14. Enter. Okay, so I've got that. I've got the USB IDs. I don't. We're just gonna hit back on that. It's not giving us anything. Looks like yes. Yep. Yep. Mini 3D V2. 103. 2 GB of RAM. I'm assuming, yeah, I guess we can just ignore these. Bootloader offset, yes. Communication interface, USB, clock reference, 8. Yep, okay. That looks all good. Do we, no. Select exit, so escape, save configuration, yes. All right, good. Make clean. It's creating the link. Now hit make. And so this is going to actually build the firmware that we're going to send to the controller board. And an important thing about firmware, especially if you're updating something like that because of how it interacts with like the physical elements. I guess boards are a bit more robust nowadays, but especially back in the day, if you did update the firmware, um, and in the process of updating, you lost power to the device, there is a very good chance that that could like brick the main board and basically kill it. So make sure you have nice consistent power while you're doing this. Okay, when completed, this creates a firmware file, clipper.bin. Oh, see, Mac. So okay, store in the folder. Pi clip. Okay, this file needs to be copied. Yep, to the board. So way to do this is to use GUI like WinSCP. Oh, on Windows or either CyberDuck or SCP or terminal. On Mac. Okay. The firmware image copy. And if the file is not renamed, firmware updates. Here's the micro. Oh, okay. So this is like a different way to do it, I guess, because this is not the way I did it. At least I don't think this is the way I did it. Hmm. Maybe it's because no. Hmm. Redact. Copy the file to the computer. You rename it to firmware not bin. Okay, let's see what the AI is saying. So yeah, that's the communication interface. Make, okay. Called clipper.bin. Yep. So it's given me the same information. Flash the clipper. Firmware port. Okay, here we go. Sudo clip service clipper stop. So this is gonna stop the firmware from running, which is probably going to. Oh, I didn't save it. Yeah. Okay. So yeah, clipper is down. Okay. So now enable the bootloader mode. Holding down the reset. Ah. Flashing method from rate often involves a special tool. It says not as fast. You need to install it first. And huh. Interesting. Yeah, printer.cfg. So it's saying that if I requires entering a special bootloader mode to be flashed. Stop the clipper service. Okay. Down the reset button for at least 1 second. Hmm. Full ID of your. Oh, okay. Okay. So maybe we can just do it this way. Maybe we can just do it this way. All right. Clipper. I guess we can just stop it. Keep it stopped. Yeah. Okay. Okay. So. Yeah. Okay. Cool. All right. So determine the full ID of your MCU. AFE. Oh. Okay. Is that the same command as before? Ah. So it's USB. USB. Leaves Maple IF00. Okay. So we already stopped the service. We are going to flash it. Insert the MCU ID. Clipper script slash sh. Dash dev dash 0. Okay. So we just gotta copy this whole thing. And we gotta paste it here. Okay. SH. Just double checking. Okay. So in theory, this should work. All right. Let's see what happens. Okay, that looks promising. Okay. I don't know if that's good or bad, if it's trying to... I don't know if that's loading or if it's just can't find anything. Hmm. Think I am going to copy this and see what this means. Because I definitely don't want to stop anything. Successfully flashed, but the subsequent failure to connect to the MCU suggests an issue with the connection. Flashing process itself. Okay. It's generic interface. Change once Clipper is successfully running on the board. MCU's new serial ID. Okay. Board will reboot. Identified as a new permanent serial ID. Okay. So it should. Unable to connect to the MCU. Okay. We will see. If the ID changed. Fingers crossed it did. Hmm. Okay, it didn't. Okay. So can I... Okay, so it looks like I will have to actually... Alright, let's start the Clipper service again, just to... where are you? Loop, timers check, okay. Service Clipper start. Let's see if the service will start. No, I keep forgetting I'm on a Linux device and you can't. That's the one annoying thing is keybinds for copying and pasting. Maybe I'm just doing it wrong, but it doesn't seem to. Oh, no. Okay, that didn't cause any errors, so I think everything is fine. Um, I just need to. Let's see. I've got a. All right, so what does it say that I need to do exactly here? So Yep, so we've got that stored in that folder. Way to do is it Julian? Okay. Pop OS move file from SSH to local. Move a file. SSH. You can use the scv secure copy command, which is SSH from the file transfer. Okay. So, all right. That should be relatively straightforward. All right, so we are going to copy this. We are going to go into a new window. And is it going to... SSH, I'm assuming it's going to be... Yes, okay. So... SCP, I've got that copied. Okay, so the path to the file is specifically, what is it? What is it? What is it? In /home/pi/clipper/out. And slash clipper.bin. And then we just need to add a space. And then the rest of the command is just the path to the destination, which in our case, I'm just going to put it in the downloads folder so we can just open in terminal. Can just do that. Yeah, it's the ellipses. Slash downloads. Do you need another slash there? No, you don't. And hopefully this will work. Okay, no such file and directory. Okay, so now we are going to go searching on here to see if we can find it. Clipper, all right. So let's first do ls to see what's in this folder. So we've got the out folder. We will do cd out to get into that folder, and then we will do ls again, and it looks like we've got clipper.bin. I might have misspelled it, possibly. klipper.bin. Hmm. maybe let's try it with that ellipses. Ellipses, clipper out. Aha, okay, success. So now we should go into here, and there it is. All right, good stuff. So again, on Linux, you probably won't be able to do that. Or I guess maybe there's another way you can do it, but it's probably easier to do it the way they recommend. Okay, so now that we've got that, it needs to be renamed, right? To firmware.bin. Copy that to make sure I don't misspell it. All right, we are renamed. Very good, very good. Yes, sure that 3D board is not powered, obviously. Then remove the SD card that is installed. Connect the micro SD card to the computer with the firmware.bin file. Oh yeah, I guess because there's a, yeah, okay. Open the micro SD card, browser, a file named firmware. Oh, this is assuming that a micro SD card came with the board, I guess. Hmm. Well, it didn't, but okay. Encountered. Format to FAT32. Okay. It's not powered with the 12 volt. Unable to communicate. The drivers. 3D. Okay. So, I guess that's good to know. Okay. I will be right back and actually get a micro SD card to use this on. Okay, I am back. I have procured a micro SD card. What is all this? Pi 0 something something. Okay. We can, is this the root FS? Boot FS, root FS. Let's take a look at disks. Let's go into the file system and see if we can find boot FS and root FS. System volume stuff. Okay, I guess this was probably for, I don't know what this was for, but probably doesn't matter. So let us format this. We'll just call it firmware erase fat. Next. Yes, format. Mhm. Okay, now root fs firmware. So we are going to get this guy. Downloads, we're going to copy, and we are going to put it in here. Okay. And I think that's all we need to do. Sorry, counter, transferring the file, reformat it. Yep. Turn on the power supply. Automatically update the firmware. Hopefully it gives me like a sound or something. I guess we'll see what happens. But I obviously won't like turn off the power. What I'll probably do is turn off the power now, plug this SD card, and I'll eject it real quick. Where's the option to eject? I guess you eject them from here. Eject. Okay. So we're gonna eject this guy. So it did actually have two partitions. Hold on. Root fs. Huh, did I use this as like a... This is kind of strange because yeah, none of these things will have like a... Yeah, let's format this too, just to... Can I format this? Hmm. Alright, whatever. Doesn't matter to me, but okay. As long as it works. Okay, so I am going to turn the power off. I'm gonna plug it, not to this computer, to the printer. Gonna plug this SD card into the SD card slot on the main board. Turn it back on. Uh, Wait and see if it gives me like a ding that the firmware has been updated. That usually is what happened with the other one when you updated firmware with that other main board. So it might give me the same thing. If it doesn't and nothing happens, I'll check back into the Raspberry Pi and see if the number changes on the MCU. All right, I will be right back and do that. Okay, I turned the printer back on with the SD card in it. The light next to the SD card reader has turned green, so it's on. So it detects that it's there. Nothing has happened so far, other than that light being on. But I'm assuming that's a good sign. Usually when you're updating firmware like this, I don't think it takes more than a couple minutes usually. So let's get back to here. And I did unplug it from the Pi, but I guess that's not really gonna matter, but yeah, it is interesting with this one that I guess you gotta do it this way. With the other one you didn't. With the other one I think you specifically had to use the MCU and you'd like send the firmware through the Pi itself. I'm gonna CD, I think it's dash, or no, it's dot dot to get, yeah, to go back. Okay, I'm gonna check back on the printer. Also gonna check and see if you guys still hear me. Yep, okay, you can still hear me. Okay. Well, green light is still on. No beeps or anything. Oh, forgot to. Let's go to somewhere else. Unable to connect. MCU unable to connect. Oh, there's the MCU error. Interesting. Now it's saying it's not ready. Okay. Guess while we're here, we can update a couple things. Finished and recompiled before the machine can be put back into service. Modified and printer CFG config. Yeah, let's just do it. Okay, let's update the system. Well, update Moonraker. Yeah. Okay, that's up to date. And then we'll upgrade the system. Because why not? Okay, now I've got everything up to date. Now we will okay, let's go back to here. Turn on the power supply. Named properly will automatically update the Clipper firmware. So it's been a few minutes. I'm going to assume that it probably is updated by now if it was updating at this point. I'm going to plug the Pi back in, and I'm going to run the command and see if the MCU number has changed. Be right back. Okay, I am back. Moment of truth. Okay, is this different? Yes, it is. Okay, I think we did it. We did it. Okay. So now that we've got this, we can go to the MCU. Yeah, so we need to go into here. Ah, there we go. MCU unable to connect. So now it's there, and that's interesting. Okay. So we're going oh yeah, okay. So now that error is showing up because we did actually get the firmware put on there. So it just wasn't detecting. Okay. That explains it because there was already firmware on the other main board, the original main board, and this main board that I got is a fresh one, so it didn't even have anything on it, which is why that error wasn't popping up before. Got it. Okay, that makes sense. That makes sense. Okay. So we're going to go into printer.cfg, and we're going to go right here, and we are going to copy this guy. Serial.usb clipper, and we're going to copy him, and we are going to paste him right here. And then fingers crossed. Save and restart. And okay. Shut down. Ah, extruder temp. Okay. Okay. This generally occurs when the heater temperature exceeds its configured min temp or max temp. Okay. And the reason for that is because the it's not plugged in. Also, a fan turned on. I'm gonna be right back. Okay, so good news. The that fan is now the fan that wasn't turning on is turning on, like the cooling fan for the hot end. So that is good. That's what turned on. And yeah, that ADC out of range. That's 100% just of because the sensor isn't actually plugged into the board. So I need to do that. I will do that. Um, but I just needed to figure out like which side is which so I don't cause any issues. But it looks like everything is working. Um, as far as now goes, that's pretty much it, I think. I mean, we can check, but we've already flashed it, so that's done. Back to software installation. Or we'll just actually go back. So firmware flashing. Yep, go back, update the controller path, so we did that. Date second, we don't have a second one, we just have one. Dating specific settings, I'll change these to the correct ones. Additional changes, Mainsail OS only. Add the following entry to your printer.cfg. That is loud. That fan is loud, but in a good way. It'll do a good job cooling it. Can probably change that. Printer.cfg. Uncomment, depending on the UI being used. Okay. So, which include Mainsail? Yeah. Okay. Save and restart. The fan just turned off. It's back on. It has the same error. That's fine. That's expected. Okay, restart to take effect. Type firmware restart. Initial startup. Initial startup guide. Mainsail fluid. Console. Okay, so I think what's gonna happen is I think I'm gonna call it for tonight. I'm going to go through all of these printer.cfg things, make sure everything is changed to properly reflect the new dimensions and such of the printer. Um, and that should be about it. Like, and also I'll also check to make sure the probe is working. Like the temperature thermistor is working. Once that's done, that error should be fixed. And yeah, I mean that's probably the long and short of it. Fact that the firmware got flashed and it's detecting that is all great. And yeah, I think that'll probably be the last one of these, maybe. Full live streams, maybe. Maybe then we'll have like a final one. I'll have like a final one of me actually showcasing the printer printing something. But we are getting close. We are getting uh, very, very close finally. I'll just have to make sure that all the wiring is actually correct and no capacitors pop on me. And I'll also have to like rewire that whole thing as well. What else? I mean, yeah, I think that's pretty much it. Uh, so maybe I'll get to that tomorrow, and if not tomorrow, maybe like next Wednesday or something. Uh, but yeah, I'm getting there. Uh, and I will see whoever's watching this in the future. you, whoever, uh, some other time. All right. See ya.